Okay, so this is the first, or question one on the extra exam 2 practice problems. So this is kind of an overly simplistic way of thinking about penalty kicks at the end of a soccer game, but there's a little bit of this that that goes on, right? So at the end of a soccer game, if it's tied and you've gone through overtime and it's still tied, it comes down to penalty kicks. And you guys have probably seen that where the goalie is there, and then each team takes turns kicking and so forth. And so a lot of times the goalie is trying to anticipate whether the person kicking the ball is going to kick to the left or the right. And they can kind of like cheat or anticipate one direction or the other. And of course the kicker is trying to decide whether they go left or right or when they kick the ball. So we're simplifying it a little bit, but that's the game here. So player 1 is the kicker, and player 2 is the goalie. So the kicker is either going to kick the ball to the left or to the right, and the goalie is going to try to anticipate that the ball is either going to go to the left or to the right. So if the kicker kicks left and the goalie anticipates left, right, then the goalie is able to stop the ball, and the goalie kind of wins that round. Now, technically, the goalie doesn't get a point, but blocking their penalty kick is almost like getting a point. So I just made it a point. Okay. So suppose the opposite happens. The kicker kicks right, and the goalie anticipates right. Again, goalie blocks the ball. The kicker does not score. Goalie wins that round. Okay. Of course, when you have the opposite scenario, so when the kicker kicks right and the goalie anticipates left, then the goal scores and the kicker wins that round. Right. And lastly, if the kicker kicks left, the goalie anticipates right. Then the goal scores again, the kicker wins, and the goalie loses that round. So these are kind of the different scenarios here. All right, so now let's walk through and kind of think through this game. So first part, does either player have a dominant strategy? If so, what is it? All right, well, let's see. In order to analyze this, let's go through. Remember, assume you're player 1. Assume you're the kicker. Kicker is player 1, and the goalie is player 2. Okay. All right, so let's assume we are the kicker, and suppose you know that the goalie is going to anticipate left. Well, then you should kick to the right, because 1 is better than 0, right? That is, if the goalie anticipates left, you go right, and you score the goal. Okay. So then same thing. Again, assume you're the kicker. And suppose you know instead the goalie is going to anticipate right, well, then you would kick left, you would score the goal, because scoring the goal is better than not scoring the goal, 1 compared to 0. Okay. All right, let's do the same thing. Assume you are the goalie, player 2, and suppose you know the kicker is going to kick left, right? Well, then you would anticipate, and you would kind of go left, and you would block the kick, and you win that round. Okay, last one. Again, you're the goalie. Suppose you know the kicker is going to kick right, and so if you know the kicker is going to kick right, you should anticipate and go right, blocking the goal, and again, 1 is better than 0. All right, so in doing this, we can see pretty quickly that the answer to part A is no. Neither player has a dominant strategy, right? Because for the kicker, if the goalie is going to anticipate left, they should go right, and if it's right, they should go left, right? So there's no choice that always makes them better off. Same thing for the goalie. There's no choice that always makes them better off. So there was no dominant strategy. And, okay. Is there a Nash equilibrium in this game? No, right? Notice how none of the outcomes has both the payoffs underlined, right? So no Nash equilibrium. Is this a zero-sum game? Yes. Right? So notice how in every scenario, one player wins and the other player loses. Okay. All right. So that means this is a mixed strategy game, right? So Nash's famous thing was that all games basically have some sort of mixed strategy Nash equilibrium. And so let's find out what it is. All right. What this means, and if you've watched soccer games when they come down to penalty kicks, you notice that the players kind of start to randomize and kick left or right, and the goalie is guessing left or right and lunges each way. And so that's what we're going to analyze here. So now what we have to do is we say, okay, assume there's some probability, and let's suppose the kicker is going to kick left some p percentage of the time, which means he's going to go right the remaining percent of the time. So if p is 50, then 1 minus p is also 50%. It's 50-50, right? And for the goalie is going to anticipate left. We usually use q here, some q percent of the time, and then is going to anticipate right the other 1 minus q percent of the time. So again, if q is 50%, then 1 minus q is also 50%, which means it's a 50-50 mix, okay? All right, so how do we solve this? Well, remember, a mixed strategy Nash equilibrium is one where each player randomizes their choices to make the other player indifferent between their two choices. All right, so let's start with the kicker. And let's figure out what the value, or the expected value, for the kicker of kicking left. I'm just going to use L so I don't have to write out left every single time. Okay? Well, this is the top row. And remember, the first payout, the first number listed, is the outcome for player 1. So the kicker is going to get 0. That is, they're going to lose that round if the goalie also anticipates left. Okay? So that means the probability that the goalie goes left is Q times the outcome. Well, the outcome there is 0. Plus, well, the probability of the goalie going right is 1 minus Q. And then the outcome for the kicker in that scenario is 1. Okay? Well, this simplifies just to 1 minus q. Okay. All right. So now let's do the expected value of the kicker kicking right. Okay. There we go. Well, if they kick right, they're going to win if the goalie anticipates left. So when the goalie anticipates left, q percent of the time times 1. Plus, well, the goalie goes right the other 1 minus q percent of the time. And when that happens, then the kicker loses, so they get 0. So this just simplifies to q. Okay? All right, so to find the mixed strategy Nash equilibrium, remember, the goalie is going to try to randomize his or her choices to make the kicker indifferent. That is, the expected value of going left for the kicker should be equal to the expected value of going right for the kicker. All right. So that means this is 1 minus q is equal to q. So let's move the q over to the right. So we're going to 1 equals 2q. That means q is equal to 1/2. And this should kind of make sense based on the payoffs, right? So you're going to have a 50-50 shot. So that is, q is 1/2 or 50%. Okay? That means the goalie anticipates left. Let me scroll back up here. Anticipates left 50% of the time and anticipates right the other 50% of the time. So now let's do the kicker. Let's do the goalie. Goalie. And remember, to do the kicker, we get the probabilities for the goalie. Remember, the mixed strategy Nash equilibrium is an interdependence. My outcomes depend on what you do, right? So, expected value for the goalie of anticipating, expected value of the goalie of anticipating left. Well, let's scroll back up here. Okay. So if the goalie goes left, they're going to win when the kicker also goes left, so some p% of the time times 1. And then the remaining 1 minus p of the time they're going to lose, which is 0, right? So it's going to be p times 1 plus 1 minus p, which is the remaining probability, times 0, okay? Well, and that's just equal to p. All right, so the expected value of going right, we're anticipating right for the goalie. Let's scroll back up here. All right. So if the goalie anticipates right, well, if the kicker goes left, then the kicker, am I screwing myself up? Yeah, then the kicker is going to win that round, so the goalie gets 0, okay? And then if the kicker goes right, then the goalie wins because the goalie blocks it, right? So you get 0 for when the kicker goes left, and you get 1 when the kicker goes right, okay? So this is going to be equal to p times, let's make sure I got this right. Yeah, so the first one, if the kicker goes left, then the goalie loses. So that's going to be 0 plus 1 minus p times 1. Okay. All right, this simplifies to 1 minus p. And again, the math is the same here, so we set them equal to each other. That means p is equal to 1 minus p. So we'll move over here. That means if we move the p over, we get 2p is equal to 1. P is equal to 1/2. 1/2. That is, it's also 50%. So our mixed strategy Nash equilibrium in this particular game is where the kicker kicks left 50% of the time and then kicks right the other 50% of the time. And the goalie anticipates left 50% of the time and then anticipates right the other 50% of the time. So that's it. That's how you solve this first one.